My friends, welcome to exercise 112 of my 200 3D CAD models in FreeCAD series. Exercise 112 is a very simple object, to be honest. The only trick here is that intuitively I would say this is a hollow pipe with two flanges with their bolt holes in there. And however, looking at the cross section, looks like it's not hollow entirely. So it's a weird object. I mean, I don't have any practicality of this object, but I'm gonna build it nevertheless. So I transferred the image on XZ plane with the thought that I will be working on the front view. So this is the one, the cross section view, and I want to build this with a simple revolve. Now on this one, it has a couple chamfers and corners around here. Previously, I preferred to have those built in into the sketches. Today, I won't do that. I'll be doing the chamfers and everything else later on. So let's go ahead and start our sketching. I'll be doing the boundary first, and then we will be working on the constraints later on. The only thing I'm missing from this sketch is it does not say how far this line should be. It does not say that. So let's go ahead and make a good assumption from our background image. It looks like 25, magic number. All right, we have our fully constrained sketch, and I want to rename that as sketch revolve. And let's go ahead and do the revolution against the z-axis or this line, and we will do a full sweep, and there it is. That's our main body. I'm gonna go ahead and do the holes. So it will be a cylinder of diameter 10, right? And height, I'm gonna say 120. And then I want to leave it there. So now we have our cylinder that I want to make the holes around, right? And I can use polar array to do the replication 6 times. And we can go about using the draft workbench and then have array tools from here, or we can go to lattice 2 workbench and then have polar array from there too. Now polar array is available in both sides, but it is important to note the distinction between these two. So we'll do it on both workbenches and then see actually how it looks at the end. So let's go ahead and use lattice 2 workbench first. Now if you are new in this series, I have a couple of videos describing the basics of lattice 2. It's an add-on workbench. You can go ahead and then install it from the tools and add-on manager, and then you can install lattice 2 from there. But the basics we will be going with polar array today. So we will add a polar array, right? And then come here and we will change the count to 6 because we want to have 6 replications. So let me go ahead and hide this revolve for now. So we will have 6 replications, and then we want to have this object replicated at 6 times around at a circular area. So we'll have to go ahead and then give the radial distance here. So radius would be, so if I remember correctly, the diameter was 90, so we will have radius 45. As simple as that. I can go ahead and take the cylinder, take the polar array, and come here and say populate with copies. We have 6 replications of our original object, and now I can go ahead and hide the original object. So there it is. six replications, and I can go ahead and then make the cut, going back to part workbench and make a cut, and then we have our object. So that's very convenient. Now let's go back and delete the polar array, and we want to show how we would do it in draft workbench. So we have a cylinder in the center. We want to make 6 replications around the circle, and then we have polar options in draft workbench. So let's go ahead and hit polar array, and here we have the polar angle 360. We know what it is, and then we have the polar element 6, and we can make the center of rotation at 0, and then we don't see the option to have a radius or like the diameter where we want to throw the 6 elements around a circular fashion. We don't have that option. So if we hit OK, we have all 6 of those polar arrays elements embedded in the same place. So this is not going to work for this specific condition. So if we want to use the polar array in draft workbench, we will have to move this object to the circular area where we want to replicate that radius. So that's one thing. There is another way though, since we are discussing about options. However, this is something very unpopular way. Nobody actually, I don't know if anybody does that, but there is a circular array in draft workbench where we can say there will be a radial distance which is 45. We have a 90 millimeter diameter, and then we have a tangential distance. Okay, I will come back to that one in a minute because I want to discuss it. And then we have a circular layer. So circular layer, which means is in a radial circular array, we can have 1, 2, 3, like multiple circles of arrays. We can do that. On this one though, the first one, the element itself is considered one circular layer. So we will have to have another layer in here. So there will be circular layer will be 2, and then we'll have symmetry. I think this is something internal calculations for the circular array. I totally don't get it right now. We'll just keep it 2 for now. There is a manual, it says it should be between 1 and 6. So let's see what 2 does. And we can reset point, and then I want to go back, actually talk about tangential distance. So the definition says it's the distance between 2 elements in the same circle, right? So before I take a minute to actually describe it, let's go ahead and then make that 10 and see what happens. Remember that we don't have the option to put in the number of elements. So we want to create 6 replications. That option is not given anywhere here, but we have this tangential distance, and that's related to the number of elements. So let's see 10 millimeter what it does. What it does is between this element and this element, the distance is 10 millimeter, right? We can take a wild. So that's what the 10 millimeter did right here on the array. When it says tangential distance is 10 millimeter, that's the minimum distance between the center of these two objects, which is really, I think it has some application somewhere, but it is really inconvenient. So we want to have 6 replications. So we want to play around with this, and then there is this count which we want to have 6, and we cannot change it. It says the total number of elements in the array. This property is read only, so we cannot change it. What we want to do is we want to play around with this. So let's say 20. So that means we have more than 6. So 30. We have 8. So we are going close. Say 35. Doesn't change anything. So 40. There. So we have 6 number of elements. Their total count is 7, including this one. But to have the one array from a center object, we would have to go through all these hurdles. So I see where this circular array is not practical for this case. So if we wanted to use the polar array from draft workbench, the bottom line is this circular array, I don't like it. What we will have to do is we'll have to move the cylinder to the circular area first. So I want to go ahead and transform it, say on the horizontal side for about 45 millimeter. We can actually fix it from here. So on the placement, on the position, on X distance, we want to say 45. Now we can go ahead and use the polar array, and here we say number of elements would be 6. We don't have to worry about the radius because it's already embedded in there, and then hit OK. So there is that. That is the distinction between polar arrays in Draft Workbench and Lattice 2 Workbench. Lattice 2 Workbench gives you the option to actually project an object from the center to a circular area, where in Draft Workbench, from the practical sense, we would have to actually throw in that main object to the circular area first and then do the array thing. Other than that, basically the same thing, and I think for like too many replications, Lattice 2 is a bit more easy on the computing side of the computer, whereas Draft could be a bit longer with the high processing time. All right, so we have discussed 3 options and then say if it was in Lattice 2, don't worry about where it is. We can actually project it on the circular fashion if it's in the center, but if it is Draft, it is important that we actually place that first object to the circular area first. And then once we have everything, we can go ahead and then take this array out of our revolve, and there it is. That's our object. Very simple object, but I wanted to take this opportunity to actually show the distinction between polar arrays in Draft and Lattice 2 Workbench. Hopefully it added to your knowledge base. If you didn't know this about earlier, I wanna go ahead and do the chamfering and filleting right now. So all these edges will be fillets, chamfers of say 2 millimeter. I don't remember the value. I'm just gonna go ahead and then do it right now, and these two would be fillets of say 3 millimeter. There, actually these two will be chamfers as well. Should have done it, but all right, that is our object. Hopefully you liked this process, and also hopefully you liked the discussion between 2 options in the polar array. If you have any comments or questions or something that I don't know of, please leave them below in the comment section. You know that I always appreciate those comments. Thank you for watching. I'll see you later.